students. In this video, we're going to go through the answer key for the Chapter 8B review. Please make sure you've tried all the questions on your own before watching this video, but then you can use this video to correct your work. If you have any questions at the end of it, just let me know. And just remember, this review looks identical to your test. Your test will look just like this, same number of questions, same order, just using different numbers and variables. So questions 1 and 2, it asks us to write the word sentence as an inequality. So we're changing the words into symbols. Number 1 says a number W is no less than negative 17. So I know I'm comparing W and negative 17. I just need to decide what symbol to put in the middle. I need to decide what does no less than mean. Well, if W cannot be less than negative 17, that means it could equal negative 17 or be more than that, could be greater than that. So we're going to use a greater than or equal to sign because W can't be less than negative 17, but it could be greater than or equal to it. And this is our final answer. W is greater than or equal to negative 17. Question 2, a number M is fewer than negative 100. So I have M fewer than negative 100. So I know I'm comparing M and negative 100. I just need to think about what symbol fewer than means. Well, fewer than is just a different way to say less than. If M is less than negative 100, this is the one that should be being eaten. This is the way our symbol should go. M is less than negative 100. And that is our final answer for question 2. Questions 3 and 4 ask us to tell if a specific value is a solution to the inequality. So here's how we're going to do that. In question 3, tell whether x equals 25 is a solution of 2x is greater than or equal to 50. So we're actually going to rewrite our inequality, but we're going to replace x with what they're telling us with this value. So 2 times 25 is greater than or equal to 50. And I'm putting a question mark above there because the goal of this is to decide if that's actually true. 2 times 25 is 50. So when we turn x into 50, we get into 25, we get the following inequality. 50 is greater than or equal to 50. That is true. 50 does equal 50. This is a true statement. That means yes, this value is a solution because if I change my variable into that value, I get a true statement, a true inequality. Question 3, very similar. Tell whether x equals 15 is a solution of x over 3 is greater than 5. So again, I'm going to rewrite my inequality, replace my variable with my value. So replace x with 15. That way it says 15 over 3 is greater than 5. Again, I'm putting a question mark because I don't know yet. I have to decide. This fraction bar is just a different way to represent division. So this means 15 divided by 3, which is 5. So we get this statement that says 5 is greater than 5. That is not true. 5 is equal to 5, not greater than itself. So we're going to say no, this one is not a solution. If I change x into that value, I do not get a true statement or a true inequality. Questions 5 through 8, we're going to be solving each inequality and then graphing the solution. Graphing the solution. So we're not graphing this thing right here. That would actually be very difficult to graph because it's not just a variable here. We are only graphing once we have the actual solution. So number 5, x plus 1 is less than or equal to 10. To solve the inequality, I'm going to draw a line through my inequality symbol. I only want the variable over here, not the other stuff. So how do I undo plus 1? I do the opposite. I subtract 1. Plus 1 minus 1 undo each other, leaving only x behind. And because I subtracted 1 here, I need to do the same on the other side. 10 minus 1 is 9. Now here's the part where some people get a little bit confused. Do not put an equal sign in between these. Copy the same inequality symbol from above. So this is our solution. X is less than or equal to 9. This is telling us as long as x is 9 or less, this inequality is going to be true. So this is what we're going to graph. This thing, x is less than or equal to 9. So I'm going to label my number line. I'll start at maybe like 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So first open or closed circle. I am going to use a closed circle on the number 9 because x is allowed to equal 9, right? It says less than or equal to. Also, when there's a line under the symbol, we know to use a closed circle. Now, x is supposed to be less than or equal to 9. So the numbers less than 9 are to the left. So we are going to draw our arrow to the left. Make sure that arrow and line are on the number line, not above or below. Also, if we had changed the middle symbol, there into an arrow, it would have pointed left as well. But remember, that trick only works if the variable comes first. All right, question 6, we're going to solve 3x is greater than or equal to 21. Again, draw a line through your inequality symbol. 3x means 3 times x, so how do I undo times 3? I divide by 3. Times 3 divided by 3 undo each other, leaving only x left over. And don't forget, because you divided by 3 here, you must do the same on the other side. 21 divided by 3 is 7. Now we're going to put the same symbol from above in our solution. X is greater than or equal to 7. So that is our solution. They're saying as long as x is 7 or more, our inequality is going to be true. So this is what we are graphing. X is greater than or equal to 7. So let's label the number line. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can choose to make your number line look different than mine as long as it has the same type of circle and the arrow in the same direction, then you're good to go. Bottom line is as long as you have this number on your number line, you're good to go. So when you're checking these, just be checking that you have the same type of circle as me on the same number and that your arrow is going in the same direction. But you could choose to number your number line differently. Okay, x is greater than or equal to 7. Well, x is allowed to be 7, so we're going to put a closed circle on 7. Also, when there's a line under the symbol, we use a closed circle. Now, x is supposed to be greater than or equal to 7. The numbers greater than 7 are to the right, so I'm going to draw my line and arrow to the right. Again, it's on the number line, not above, not below. Must have an arrow. Because the variable is first, you also could have turned your symbol into an arrow, and it points to the right, just like our graph. Right, then we have question 7. So we're going to solve x minus 5 is greater than 10. Draw a line through our inequality symbol. How do I undo minus 5? Well, I do the opposite. I add 5. Plus 5 minus 5 undo each other, leaving only x left over. And because I added 5 here, I need to also add 5 over there. 10 plus 5 is 15. And then finally, copy the same inequality symbol from above. So our solution says x is greater than 15. As long as x is greater than 15, our inequality will be true. This is what we're graphing. Not this, but our solution. X is greater than 15. So I'm going to number my number line. I'll go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So first, do I use an open or a closed circle on 15? I'm going to use an open circle because x needs to be greater than 15. It's not allowed to equal 15. X is supposed to be greater than 15. The numbers greater than 15 are to the right. So I'm going to draw my circle, my line and my arrow to the right. Again, the line's on the number line. There's an arrow. It's not above or below. We could have found that arrow direction by turning our symbol into an arrow since the variable comes first. And also we could have known our circle was open because there's no line underneath the symbol. And finally, question 8, we have 3x over 4 is less than 6. Draw a line through our inequality symbol. Now there's two things happening here. 3x means 3 and x are multiplied, and then that entire thing is being divided by 4. So that means I have two things to undo. First, I'm going to undo the divided by 4. I'm going to do that by multiplying by 4 on both sides. Times 4 divided by 4 undo each other. That does not mean only x is left. It means we have 3x left, right? I have not touched the 3 yet. 6 times 4 is 24. So now our inequality says 3x is less than 24. To undo this 3 that's being multiplied by the x, I'm going to divide by 3. I'm going to do it on both sides. Times 3 divided by 3 undo each other, leaving only x left over. 24 divided by 3 is 8. And then use our same symbol from above. So we get the solution x is less than 8. This is telling us as long as x is less than 8, our inequality will be true. So this is what we're going to graph, not this, but our solution. So I'll number my number line, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If x has to be less than 8, it's not allowed to equal 8, so I'm going to use an open circle. Also, there's no line under the symbol, so we're going to use an open circle. X needs to be less than 8. The numbers less than 8 are to the left, so I'm going to draw my line and arrow to the left. Also, since the variable is first, you could change your symbol into an arrow, and it would point the same direction on your graph.